So we are being recorded at this time. This is Josiah again, and we are starting off our 18th day on IT Foundation and AWS Cloud Training, codename iFACT. The implementation partner to this program is Each One Teach One, and the sponsor is Lost and NLC. And today we are going to pretty much continue what we stopped. We're going to work on CISSP domains. We did 1 and 2 last time. And we're also going to take a look at our Python and see some of the work that you guys have done. I wanted to make sure that most of you guys have tried the backup thing that we did in the last class. And I also wanted to make sure that some of you guys understand how the coding in Python is, that it's not that complicated, that pretty much everything is simplified. I would like for you guys to put a lot more energy into Python than anything else that you've done, because that language is rising, it's fast approaching to its climax, meaning that a lot of people, it's going to gather critical mass. A lot of people will know it. Those who know it will have the future jobs. And some of the languages that are dying out, you could Google it on YouTube or YouTube it to see the languages that are dying out, so you will know what languages not to mess with and those to mess with. In times to come, Python is the way to go. It's very, very straight to the point, well structured. The syntax, idioms, and grammar are very clean and neat. That's what I like for you guys to understand. And some of you guys are understanding it very well and applying it and seeing how it works, especially with the module that we've learned to see how they do it. It's very simple. Other languages, we have various moving parts, but in Python, it's straight to the point. Okay, does anyone have a question that they wanted to ask? If not, if there's no question, we'll go back to the CISSP and we touch base on some of the stuff that we left behind on CISSP, and we continue with our life. Any question, guys? Can you guys hear me? Am I audible? Is it loud enough?
Yeah, I can hear you. I actually couldn't get it. I don't know. We're trying to work on something, but I had some little difficulties.
You had difficulties with the module?
Yes.
Okay, I can help. No big deal. So, is that your line of code that I was seeing? If you can open it and share with all us, I can actually point.
Okay.
I can point to 1 or 2 things for you to straighten up, and then we can move forward. I don't think it's that complicated. I think Janelle was doing a good job with it. So let's just go ahead and look at it now. Thank you.
I do have a quick question while Edicon's doing that about the version. Do you have to specify the version each time, or when we did it in the demo,
the version
did it automatically look for
the version is up to you. So the idea of the versioning is when you're writing a code, you might have one idea in one code, and then you change that idea to another thing in another code, and so on and so forth. So when you have the initial code, it's usually 1.0, right? Then when you make amendment to that code, and now it's a newer version to whatever you had before, it's going to be 1.01 or 1.2 or whatever you choose to call it. That's basically how that's obtained. So this is Edican's code, I believe. He's sharing it with us.
Okay.
So, yes. So area of triangle, half base times height. So where is the problem? I read your code here.
Okay.
Okay.
Okay, let me try to run it.
Show me the other side of the code, the implementation part of the code, please. Show me the other file.
Okay,
you need a space after the comma.
This one?
Where exactly?
So print version. Oh, okay, I see. Module calculate triangle 00, that's correct. Import cloud module. Make sure it's the same name. Okay, that's the same name. Then print version, cloud module cloud module dot version is already equal to 1.0. This code should run. This code's supposed to run. What's the problem? Go run it. Let's take a look. From the error you get in, we can figure out the problem.
Okay.
Yeah, run it. Let's go.
Okay, this is what I got.
So are you in?
Just like
Where
what's
did you
missing.
put the files, the 2 files for the modules? Where did you put them?
Okay, I put them on my C drive.
Okay, can you go to your CMD, your command prompt, right there where you are on the prompt, and do dir? No. Go to your command prompt.
Okay.
Yeah, do dir. Yeah, put dir there. Let's see where this thing is.
Okay, I've done
Okay,
that.
they are right here. Okay, all right. Oh, I know. I have an idea. Okay, remove the
Okay.
pi. Delete the pi cache. Delete the pi cache. Delete it.
Okay.
Yeah, go. The way to delete it would be to go back to. If you don't know how to do it on CMD, just go back to the directory or the folder where is it at, and
Okay.
then delete it there.
Okay.
I think it's in another folder called Cloud Movement from your directory. It's in the another folder. There's another
Okay.
folder here. Look for that folder, Cloud something.
Okay.
Oh, it seems like you're not moving anymore. Is there any reason why your screen is not moving?
I think the network here is bad. Can you see it?
Or it's like,
I can see.
oh, some people can see it, but me, I can see it, but it's not moving.
Okay.
Have you deleted the pi cache? If you deleted the pi cache, go back and run the command. The code should run.
Okay.
You can hit the upper arrow again. Try
But
it
it's
like
still
once.
there.
For me,
There we go. Okay,
I can't see what it's doing for
you
me.
can see it. Oh, we
But
can
it's
see it.
okay. So
Cloud
some of you guys can see it, so that's fine.
module underscore demo.
Okay, I'm still having the same problem.
But it doesn't look that he deleted it. Why is it still showing on the screen?
Do DIR again?
Yeah, click on DIR. I
Yeah,
can't
so
see.
do
I can't
DIR.
see what you're doing, but some people can.
Okay.
It's still there. So something
Still there.
is still there. You have a directory.
Okay.
So that's coming up as.
He's not in the right directory because I saw his directory here. He skipped it. You have to look for cloud. That's cloud movement right there on the left. That's
CMD and opening.
That's the cloud movement right there. I see it on the left. Click on that. That's where the underscore. That's where all your stuff is in. No, it's
Let
not
me.
there. Okay,
It's
yes.
here.
Go to cloud movement. Click on yes. You see, this is where it is deleted. If once you delete it from here, then you can that code will populate another one, another case because let's just do that. It will work.
Okay.
So you have to go to change directory and then copy paste whatever that is. That's how I would do it.
Hello, can you hear me?
Yeah, I can hear you.
Okay.
I don't think I can see it, but then some of our team members can see it.
GCD dot.
So you have to,
Yes,
yes, you
CD.
have to go up a level twice so you can get to
And then
C. Yeah,
CD again.
Okay.
awesome, guys. You guys are working together. That's the secret right there. That's how the
And
Chinese.
then
Okay.
That's how the Chinese did it.
then did that's right. Do you
All right, Josiah.
Okay, that's it.
We're on our way.
do
You saying something?
DIR?
Yeah.
Mm-hmm.
Yeah, you have to
Okay.
emulate winning strategy. That's it.
Okay.
Okay, so PyTest is there. So then
I test.
I think is it PyTest to do PyTest DIR?
Yes.
I
What
test.
what
Yes.
he has to do is change directory to PyTest, and when he gets to PyTest, he'll
Mm-hmm.
change directory again to Cloud Movement. Once he does that,
Oh,
you
Okay.
do dir, and then he's gonna see those two files that make up the module. One is the actual function that have all the characteristics of what he wants to do, and the next one is the implementation, which in other languages they call it driver. Then when you call that particular function in the other file from the driver, it will then run whatever that's in there. Basically, it will implement it.
so is it PyTest dot that?
It's
Okay. I test.
you have to do cd. No. You have to do change directory. You have to cd stand for change directory. You have to change directory
Okay.
to PyTest
Also CD
Okay.
PyTest. Sorry.
space PyTest. Okay. Let me just focus on
Okay.
taking care of this with him. All right. Push enter. Then
Okay.
you go into that. And now do a dir here. You're gonna see a bunch of files and folders. Just do a dir.
Yes. Okay.
It's taking him forever to do it.
Okay. Can you see this?
I can't see anything because you didn't type anything.
The network is very bad. I don't know. It's so bad today.
No, like because it's not showing.
Oh, okay.
It's not.
Okay.
It's not showing
Okay.
the folders.
Okay.
CD cloud
Now do
movement.
CD cloud movement. I think your stuff is
Okay.
in CD cloud movement. That's where your stuff is at.
Okay. CD Club.
Yeah, push enter. You will see your files and folders in there. Actually, your files will be in there for the module. dir. dir to show up.
Okay.
You see, it's right there.
Okay.
So you want,
Hey.
Yeah.
so you wanna go ahead and do Python cloud module underscore demo.py, or you can just do cloud module underscore demo.py. I hope you
Okay.
have the version of Python on your stuff anyway.
Yes, I do.
Good for you. Go ahead and run it. Let's see.
Quad module
Underscore.
demo.py. Wow, wow,
I think
wow.
you have to put
Write it again
you
with
want to
Python in front.
Python, yeah.
Okay.
Yeah, you can put Python too. It'll work.
You're fine.
You so slow for the
Check your
network is slow.
spelling.
I can't see his stuff, but I'm glad
Okay,
some of you
insert
guys can
file in
see
my
it.
directory.
Okay, it says Python
Okay,
can't open file. Oh, you spelled it wrong. Inside your code is
yeah, I see
wrong.
that.
Inside the
Yeah, yeah.
code somewhere is wrong. So let's go back to your code and correct it. Maybe the in somewhere inside the code that thing is popping up.
Put a U after the O. Put a U after the O.
But
You.
he did it right.
Other
Oh,
way
you.
around.
Oh, you. Other
Okay,
way.
okay.
Okay, she saw it. She saw it. Yeah, correct that.
This is how we're learning, right? This is cool.
Okay,
So we're all seeing this.
okay.
We're gonna get it this time.
So
Enter.
once you get it, nobody can tell you what it is because you did it and you saw it and you never forget it. So now
Oh, so the
take it
same
easy,
thing.
take it easy. Let's look at it step by step.
Why is there that space between X and Y?
So now let's look
See,
at
I
it
can.
step by step, guys. It says that the file cloud module line 2 in module cloud calculate underscore triangle XY name error name X is not defined. All right. It says that the name error name is not defined. So let's go and see why he's having that problem. For me to do this, I have to go and open my own code base, and look at it from my own code base. So we'll figure out why he's saying that the name X is not defined. That means you've used the X in somewhere else that you weren't supposed to be using it. That's the only thing that I can come up with. But I will try to see if I can help you. So let's look here.
He said the problems with line 2.
Yeah, that's what it says. So I'm trying to open my own line 2 here to see how we can solve this problem fast so that we can move on with what we came here to do. Okay, I like to solve individual problems because individual problems is power. It means that that individual knows that thing, and then that individual can help another person, and it saves time for all of us. All right, there are a few things here that I noticed in your code. When you did the calculate triangle, that space is a little too much. Somebody mentioned that.
Okay, over here.
The space after the comma is a little too much. And the next thing is, well, I don't see anything else. Okay, let's go back to the other one and see why the x is not defined. How did you use the x in the demo.py? Let's see. Let's see how you use the x in demo.py. Give me a minute here. For now, you are sharing the screen. Okay, so
Because that's what I have. Module version. Well, you're printing module version, cloud module version. I don't know. It looks the same to me.
so now from his can you open yours? Let's compare with mine, please. Open yours. Oh, I can see yours, no problem. So let me compare with mine. Meaning, I'm not going to share the screen, but I'll just compare it and I'll tell you guys what I observed. Go back to the cloud module, please, Edicon. Let's go step by step. Open that one for me. Okay. So you define the function calculate triangle xy. Okay. You printed like describing what we're about to do, and you do x int. So you ask the person to enter an integer, and enters an integer, and you assign it to x. Okay. Okay, you did that, and you ask for y, and you assign it to y. And you went to the area. Can somebody mute themselves, please? So you went to the area. Can you mute yourself, please? So for the area, you put the home mat that helps you with the area. That's fine. Oh, Edicon is gone. Can you guys hear me? Okay, he's back.
Yeah, I can hear you.
So this one is
Yeah.
correct. So let's go back to the demo and see what you did wrong in the demo. Okay, that space there is a little too much for the zero, the two zeros. Okay, so let me read it carefully. Cloud module calculate triangle 00 print cloud module dot. Your code is supposed to run. Save it again and run it again, please.
Okay.
But there's too much space between the zero. So in that one right there, so
Yeah.
it's 0, 0.
You have to correct that space. It's too much space there.
Okay.
So this code is supposed to run.
0, 0.
Yeah, this supposed.
And then
this
save
code is supposed to
yeah.
run. Save all of that and then try. This is supposed to run for
Save.
It's supposed to run. I don't see any reason why it shouldn't run. It's supposed to run. This code must run.
Okay, let me take it back to how I saved it initially.
So
because
it
still
said line 2. In line 2,
yes.
X defined triangle. Check the spelling of that defined triangle to see if it's the same thing as when you called it in the implementation part. When you call that function.
Okay.
Check that. Check that line 2. Define cock triangle. Check if it's the same in those two files.
Module.
You can move the CMD out so people can help you look at it.
Okay. This is line 2.
Line 2 is where you defined the function.
Okay.
And that's where it's telling us that something is wrong with X. And you've corrected and making sure all the spaces and everything is okay. So in that case, then you should go ahead and run the code. If you know that there's no wrong spelling with when you call that function at the demo of pi. When you were calling the function at the demo of file, if you know that it's not like you see, okay. Did you spell the triangle cock underscore triangle wrongly? Go back.
No, I spelled it correctly.
It's correct. So run the code again. Let's see. This one, everything looks correct, but your code can't run. Wonder what that is.
Yeah, something is definitely
something's wrong
with Python. I would, yeah. That is weird. Is it saved somewhere else? You have 2 folders? No?
This is weird.
Let's see.
But this works for everybody else except for you.
Yes.
You know what you can do? You know what you can do? You know what you can do?
What?
Go to the cloud movement, remove those things from the cloud movement, meaning cut it from there and paste it in PyTest.
Okay.
And run it directly from PyTest. Let's see if there's a difference there. Because it's going folder in folder. They're not what I expected. Just copy.
So that's there.
Remove that, then copy. No, not like that. Go Go into PyTest. Open PyTest. Now paste those 2 files here directly, not inside that cloud movement. No. Do not paste it inside the cloud movement. Just paste it right there. Let's see the difference.
Okay. Paste it here, right?
Yeah, open the cloud movement. Whatever is inside it, come back out and paste it on PyTest. You're not following instruction, you know.
Okay, paste it on PyTest.
Yes.
This is PyTest. Yeah. And then I paste it here, right?
Yes.
Okay. Okay.
Just go to these 2, cloud module and cloud module underscore demo. Click, like highlight them and cut them. Cut it. so that it won't exist here no more.
Okay.
Yeah. Then you go to PyTest, test it on PyTest.
Okay.
You should be able to run. Why are you going back into cloud movement again? I said go to PyTest and test it. Okay,
Okay,
like
actually,
that. This is good.
yeah.
This is good.
Yes.
Now
Okay, so
go to PyTest and run it.
okay.
Yes. CD
Change your directory.
dot. You have to change the directory. CD dot that will take you one step back. Exactly. Don't do it again. That's enough.
Okay.
Oh no.
It's under PyTest.
You should have left it under PyTest. You did CD twice. You went to C. You should have done CD dot just once. It will take you to where the file is. Now what you need to do is change the directory to PyTest. That is where your file is.
CD PyTest.
Do CD PyTest.
CD PyTest. DIR. I would just do DIR just to make sure.
Okay.
So there's your. Okay. And then run your Python cloud module demo. Yeah, something else is going on. Because it should work.
I think I'm going to delete it and then start over again if that is it.
I want you to do something for me. When you type Python on CMD, just Python, enter. What do you get?
Hello?
Yes? When you type
Okay,
when you type Python on your CMD, what do you get?
Okay.
Just Python. What do you get? I have a feeling that environmental variable might not be set properly here. That's right.
I think, can I make a suggestion? Because when you typed in DIR, you see Cloud Module Pi, you see Cloud Module Demo, and you see Cloud Movement. What's in the Cloud Movement folder?
There's nothing in there. It's okay.
There's nothing.
There's nothing in there.
Okay.
That's not in the where. But what I'm thinking that's happening here is when he runs his code, for some reason it's not working well. I'm thinking environmental variables because when he types Python, I can't even see.
PyCache is back up there, Teach.
No,
it's generated
not
again.
there. It's not there because the code, he didn't even run the code. It's when you run it, you try to run it. I can't see, actually, to be honest. What do you guys see?
PyCache.
Oh, PyCache is supposed to be there because it's converting. That's how it interprets what you wrote to the computer. The reason why I asked him to remove it the first time was because he got it from a copy from someone else. So it's not his. So he has to do another one to reflect the environment he is in. That's why I told him to remove it. Now it doesn't work for him, so we cannot do this forever. So you can get with one of us here to help you. So he's saying net error X. Did you have a capital X or you have a small letter X? That's another thing you might want to consider.
Okay, let's try that.
You might want to consider, am I using capital X somewhere? And while in fact I have a small letter X somewhere else, which is possible.
So again, this file is located, if you look at the top and went on PyTest Cloud Movement,
smaller X is what you need.
But it's in a different file. Do you guys see what he's, when you keep opening it, it's in your PyTest Cloud Movement. This file here is in a different location. So you do have files under Cloud Movement if you deleted them, but it's still going back to that. It's like the path or the way it's looking for the file.
No, he's already on the right path. He's already on the right path. But to be on a safe side, delete the Cloud Movement. So you wouldn't confuse a lot of people. Just delete the Cloud Movement. It's gone. So let's just say Cloud Movement, delete it. It's gone. It's gone. Now you can go back and run the code again to see what you get. If it doesn't run this time, then we have to. Okay. Go and run it. I think you're probably gonna run this time.
Do you just put the cloud module?
Okay.
No, you have to exit from there. You have to exit from there because it won't run like that. You're already in the. Yeah. Thank you.
Okay.
You do exit bracket and then you come out of it.
Okay. Okay. PyTest, right?
Yeah, you have to change directory to PyTest.
CD.
Okay.
Change directory. You cannot type PyTest and expect it to go to the place. You have to change directory. Okay. Now.
Okay.
No, CD is change directory. You already written CD. All you have to do PYTEST. No, you have to do CD PyTest.
It's not there.
CD PyTest.
Because the command PyTest is not recognized. It's not a container command, so it's useless. So you have to give it the command.
Okay.
Do a dir to know what's in the directory before you start carrying on. I would think. Why the space before the dir? I don't know, but it will still work. All right. Now run the thing. Let's see.
Erika, your auntie is calling you.
Now, do we need to get rid of the PyCache there, or does that matter?
Not necessarily, because it came from his environment. You should be able to override it.
Okay.
You should be able to
say Python.
I think his network is slow again.
Can you hear me?
We can hear you.
Yeah, we can hear you now.
I can hear you, but I don't know what's going on. To be honest, I can just hear you.
Python. Type Python.
Okay. Cloud. Cloud move. Okay. Okay, I think I'm going to start all over again.
You need to figure out what your problem is. Is this not the right time? But we'll move forward. We spent a little bit of time with you on that.
Okay.
Awesome. So we're gonna move forward. Okay. I don't know,
Okay.
what's going on in your environment, but everybody else was able to do it successfully well. Is there anybody that
Okay.
didn't do it well? I guess everybody did it. I heard some couple of people, they got together and did it together. All right,
Yeah,
guys.
I'll work with him on that. I'll work with him because it was the same thing that I had. So we'll have to, I'll work with him.
Okay, there you go. Somebody's gonna work with you, man. Should be happy about that. So last time we did CISSP 1 and 2, and we did also 3 and 4. And today we want to do 5 and 6, but it seems like nobody's done 5 and 6 for us still.
I'm sorry, I have 5 and 6 by Tuesday. I'm so sorry.
Oh, you already done it, you say?
No, I said I'll have it for Tuesday.
Yeah, for Tuesday. So we're gonna do 3 and 4. Hopefully we do 7 and 8 today. Okay, guys. I want to knock out the CISSP and give you guys an opportunity to see what's out there in in security. And I see the video Janelle posted not too long ago. That's the woman that wrote that book on CISSP. She's the queen in that area. So you might want to check out that video. It will be an inspiration for you. So now we're going to talk about the domain 3 of identity
That
access.
wasn't me.
Oh, it was who was that? Was it um Natalie or Aziat? I think it's Aziat.
I think it was Azia that posted it still.
Yeah, it was her. Is Aziat here
Good. I'll
with
check it
us?
out.
Yes, I'm here.
Yeah, that video that you posted, she's the queen of CISSP. Actually, she wrote the book, to be honest with you. She's on fire, that lady. So that's an inspiration right there. So we're going to treat some of the domains that we have left, like the identity and access management, concepts and security models. So you have a subject. A subject will be a user, right? And when you look at the entity, look at word, the word itself called entity, and you're thinking to yourself, "Oh shoot, this is an entity." And just give me a second. There's something I wanted to share with you guys. It's an interesting material. I'll get it so that will it will help you guys to get the whole idea of identity access management. Okay, guys, just give me a few minutes here. I will get it. It's something special that I made, but I wanted you guys to, have that knowledge. It's something I'm using internally, but I wanted to share with you guys. You guys can hear me, right? Hello?
Yes.
Okay, thank you.
Yeah.
I wanted to share it with you guys, and I hope it helps you guys understand identity access management. So in identity access management, you have the subject, the user. These are active entities. So when we say entities, what are we talking about? Entity could be what and what and what? Any ideas?
Corporation?
Corporation, server, you and me, any other objects or data within an object. Like all this stuff that we're talking about when we talk about function and we define objects in a function, that's for OOP, object-oriented programming. We'll touch that later. These are entities. Anything you can give attribute to is an entity. So I'm gonna show you guys this, and I'm sure some of you guys will love it. All right. So this is one of the ways we want to control. Let's see. This is one of the ways we want to control some of the entities that we have. So every entity will have attribute, and that attribute gives them what? Let me see who's gonna get it. The attribute to an entity gives it what? It gives it what?
Are you looking? Control gives it or something like that.
Is it identity?
That's right, identity. It gives it identity. You got it. So I'm going to share my screen and show you guys basically what identity access management entails and all that. little stuff so that as we move forward, you will not be confused any of that. You will like pretty much be like, okay, this is practically how what it is and all that. Okay, I'll just show it to you guys now. Sharing my screen. Give me a few minutes. All right. I always, all the time enjoy sharing new ideas with you guys. Okay, so I have that here. I moved it from the other computer to here. Can you guys see this?
Yeah, I can see it.
Is it clear? Do you want it bigger? Huh?
Hmm.
It's too big now. Is it okay now? No?
Can you make it a little bigger? A little bigger?
Okay, what I will do, I'll just copy it and put it on Paint because I was doing it from
Okay.
Skype thing. Okay, let's do it, put it on Paint so that we can play with it, whichever size we want it to be. Yeah, we put it here and we can play with it. All right, this is more like it. So now we're gonna kind of resize it so that you guys can see. Okay, is this good?
Yeah, that's better now.
Okay.
That's good.
So basically, what's going on here is we have a process for identity access management using a plugin. So the whole idea is you have to define their entities. Entities examples are servers, groups, business units, objects, and departments. Once you define the entities, the next thing you want to know is you have to use their attribute to give them identity. So to register, they're gonna need what to register, guys? They're gonna need attribute to register. Username is an attribute. Password is an attribute. Address is an attribute. Phone number, email, these are attributes. So once you are registered, it means that your identity is known. Okay? So the identity is known because of the attribute that you use to register. You see? So with the identity known and the attribute that you use to register, there is a way to combine those attributes so that you can have control of the subject or users who logged in. Example, read, write, execute. These are three things anybody can do in any computer system in the world. Based on how you logged in, if you use your username and password, or maybe two-factor authentication or biometrics to log in, that gives you the power to do all of this. What's in the middle there? Then if you use only maybe your password to log in, that's what you know, which is this, then that gives you the power to maybe only read something whenever you have access to. So in advanced authentication, you have what you are, what you have, and what you know. This is how advanced authentication works, and these are what is behind identity access management. Other people viewed it differently, but the main important thing for you to note is that the users must have attributes. Attribute gives them identity, and the identity has to be controlled to secure the environment. So that's that. And now let's move on to
That is sick still.
huh?
That is raw sick.
You like it?
Yeah, it's raw sick. It's ill. It's sick.
Okay, that's nice. So that's giving you an idea of what's going on when we talk about identity access management. That's the system we are using, okay? But other people have various other implementation that they have. All right. So now we know that it has to be in subject is the user, and the user active entities are what we're referring to. They could be objects, servers, data, you know, etc., etc. So different users have different access levels. Like you saw when I said register, there's also unregistered user, meaning they're not registered in that network, but they can use other means to register, like open authentication, like Facebook. They can use Facebook to log in or Google to log in. So when they use Facebook or Google to log in, the one that they're accessing their stuff from extracts specific information, but they're not telling you that. We do know because you can't have access to any system if you don't give up something. All right, all right. So there's different access. Like if I'm working in a financial institution now and I have access to the vault, I'm not gonna have the same access as the teller. My access is different. That means I have role-based access based on what I do in that bank, and every other person have role-based access as well. Okay. There's also rule-based access, etc., as we'll learn as we move forward. So we know what the subject is. What about the object? The objects are the resources that you're going to be interacting with. Okay? These are going to be entities that contain information. So you can have a server that contains information. A server could serve two ways. A server could be a subject as well as an object. When a server is a subject, that means the servers are accessing another server, and the server now has become a client to another server. That makes it a subject. But an object is a resource that serves others. So, example, passive entity contains information. You have file, record, memory location. These are resources on a computer, central processing unit, etc., etc. And there's other peripherals. So the reason why access must be controlled is the reason why you have identity access management. Identity access management tells us that any footprint left online is by an entity, and the entity usually have attributes that gives them their identity. In that case, we have to manage that, not only to control for control reasons, but also to protect resources, protect data, and secure the perimeter. So ability of subjects to perform a task or interact with objects, flow of information between a subject and object. There are security models that define interaction between subjects and objects at a moment in time. Security models are as follows. So there are various models out there. I will go through a few of them, like the Bella Padula model. Bella Padula model is distinct. This is pretty much a French guy that came up with this with an English guy. So the model is focused on confidentiality. It prescribes mandatory access control rules. It uses security sensitive labels on objects and clearance for subjects. Every object must be labeled from the most sensitive top secret down to the least sensitive public. Remember in data classification we have something like that. But data types classification is not the same as data classification. Remember when we did 1 and 3, when we did domain 1 and 3, we learned that there. And now as we go on identity access management, which is domain 3, when we did domain 1 and 2, sorry, and we're doing domain 3 now, we're learning how it applies again. It's popping up again. So in Bella Lapidula, you have to look at the sensitivity of the object. So every object is labeled. Every object gives resources, they are labeled. Okay, from the top secret to the least sensitive, which is public. So you have to remember this, that the more sensitive and resources, then the higher the rating for its security. Data classification will be rated very high, so it will be top secret because it's very sensitive. So the least sensitive is the public information, which most state websites will have for the public, and these are public information because they are the least sensitive. Systems are divided into subjects and labeled objects. See? Systems are divided into subjects, which are users, and labeled objects. It consists of two principles. It's talking about Bell-LaPadula model. It consists of two principles: no read, no read up, meaning can't read higher than your classification. So if I'm in a bank, I'm a teller, I have a role-based access, and that role-based access is to perform the teller duties. That simply means I cannot go inside the vault. That also means that I cannot see over issuing loans with customers that come in. So we have to look at how all these things apply. This rule also made it sure that you cannot write down. So if I'm working on a high level, I'm a manager in a bank, I cannot write down, meaning I can't modify something that the teller did. Because if I did that, it would have allowed me opportunity to change documents and information that are important. Okay, so I don't have access, I don't have visibility to what the lower level teller person did. So this prevents subjects with access to higher level data from writing the information to objects of lower level data. No copy and paste into lower class to prevent leakage. Data leakage is prevented when you cannot do a copy paste. So we are in a culture of copy paste. You see how copy paste seems not to be the best thing to do in places like sensitive information, where sensitive information are needed to be guided, where they need to be guided. So we have to be careful with that. That's the method for Bell-LaPadula. These are the two principles: no read up and no write down. And then we got to go to Biba model. So for Biba model, no write up and no read down. So the one is the opposite of the other. If you look at it, this one is no read up, right? And the Biba model is no read down. And the Biba model also is no write up. And then the Bell-LaPadula is no write down. You see, one is the opposite of the other. So that's how we remember the two. So it focuses on integrity. It makes sure that data is now modified without proper authorization. Subject cannot read object of lesser integrity. Trust level and subject cannot write data from a layer of lower integrity, as objects of high integrity are not permitted. So you cannot write up. So if you're in a teller, you cannot go and change the document of the manager, which is higher up. The more sensitive data are up there. It could be confidential information. You can't write up, you can't modify it. And now, if you are a manager, you can't read down. You can't read the information of the teller. So these are one of the ways to secure the flow of data. Okay, so in identity access management, these are necessary. These are some of the models that I use. So we have the Clark-Wilson model. This one is not concerned with integrity. We have the non-interference model. This one is preventative controls are in place to stop interference. This one is pretty much for data interference, meaning pretty much sort of like somebody coming from being a third party coming in and changing information. So this one stops that. We also have the Brewer and Nash model, also known as WAL, Chinese wall, I guess. Conflict of interest. It prevents users from accessing other users' files or information. So there's a product called Tripwire that's being used to make sure that everybody that accesses a file is noted, and it makes it impossible for you to get away with, subterfuging the principles. So it's called Tripwire. You can Google it and get more information on it. So some of these tools that are designed by these models ensures the protection of data, making sure that the users, they are subjects, and the objects, which are the resources, they work in harmony. So there's also the Graham-Denning model. It consists of set of objects, a set of subject, process, domain, and set of rights include create objects, create subject, delete subject, read access right, grant access right, delete access right, transfer access right. So that's another model there that does plenty of stuff. So we have the Harrison Russo Omen describe authorization. So you have a daily access management. Remember when I was introducing module 1 and 2, we talked about authorization, and we talked about what? We talked about availability, confidentiality, and integrity, which are the what of security. What are those? Can somebody tell me? Availability, confidentiality. What are those? Everybody here?
Yes.
Hello.
Here.
So what
Is
is
it raining where you are?
so what is the confidentiality, availability, and integrity? What is it to security? Do you remember what we discussed in the 1 and 2 domains? Are you guys with me? Are you guys with me? Hello? Hello? Are you guys with me? Oh my goodness, what's going on? We're having
It's the main
problems.
one. It's
What?
the main one. These security concepts.
Okay, that's the tenets, right?
Yeah,
The tenets of security, right?
yeah.
Awesome, awesome. So that's what I wanted to make sure that everybody remembered. Okay, these are the tenets of security. So moving forward here, we're gonna continue what we are doing. So we have the Harrison rules of Allman. It describes authorization. So authorization is treated differently. It's called triple A, authorization, authentication, and what? What's the next one?
Sorry, say it again, please.
There is authorization, there's authentication, and there's access control. So there's something called triple A in security. And some people are saying that it has changed to four, those in the financial industry. Okay, it's accounting, not access. So there's something like this, it's a framework actually. Triple A framework. So in security, you have a triple A framework where you have the access, where you have authorization, authentication, and accounting, where you account for who's got the access, etc., and stuff like that. So that's some of the fine part of what we're learning here that comes to mind, and I wanted to remind you guys of it. So there are also common criteria model. These are summaries, and I'll encourage if anybody is going to do CISSP to go deeper into this. So these are there are common criteria also used by organizations to ensure that they are purchasing a product that was verified to behave securely as measured against internationally agreed specifications. It applies to many devices, such as operating system, that are network devices and smart card, etc., etc. In the state government, they have a STIG, STIG, which is it's sort of like an operating system hardening procedure that is applied and is recommended by DoD. So for those of you already in security, you can check that out. Security Technical Implementation Guides. These are some of the implementation of security that you see that's been used in many private, not necessarily private, but mostly government entities. They use these, and it's backed by DoD, Department of Defense, and it's a really solid way. People get paid because they know stake, and they get paid. Mucho dinero. That's a lot of money in English. So, can you guys hear me?
Yes, I can hear you.
Awesome. So there are also vulnerabilities of security architecture. Vulnerability, can somebody tell me what a vulnerability is? Who wrote this paper? I want them to be a part of this.
What section are we on, please, Josiah?
Domain 3 is identity access management, page
Okay,
49. Page 49
okay,
on IT iFACT guide.
okay.
So who can tell me what vulnerability is? Vulnerability is a weakness in a system. For instance, if I was born with one eye, my vulnerability is that my other eye is blind. I cannot see on that direction. That means I don't have 20/20 vision.
Means that there's a high risk for possible attacks.
Yeah, vulnerability is a weakness that makes a system or entity or anything susceptible to attacks. Without a vulnerability, you cannot attack any system. So it goes like this. You have a threat, right? A threat agent is something that can do what? That can cause harm to the system. And then you have risk. Risk is the possibility or probability that a system could be exploited. Okay? Now you have vulnerability. Vulnerability is a weakness in the system. If a system have a weakness, then it means that it could be exploited. Somebody can take advantage of it. And how can you take advantage of a system? So you have to have a payload in the exploit. That payload in the exploit will do what? We plug into the vulnerability. An example will be in Windows, any Windows operating system, let's say Windows XP that doesn't have Service Pack 3, you can actually hack into it. Okay? You can use, can somebody remind me of a tool we can use to hack into any system like that? I know some of you are in security. Maybe one person is in security. Okay, there's a tool called Metasploit. All right, there's a tool called Metasploit. I used to have it on my system, on my other system, but I don't think I have it here.
I've heard of Wireshark. I've never used it.
That's for network analysis, right? You have to use it to see whatever is going on under the wires for network. And I don't know a lot of people that have used it to hack, but it just do analysis and stuff like that. And then you have the Canon Airbell. You can use Canon Airbell to hack into a system. You can do man in the middle with Canon Airbell. And then Metasploit, oh goodness, this is the Swiss knife of hacking, man. Metasploits with Netcat, you can hack into anything hackable. So maybe I should introduce some of you guys who are very curious to Metasploit. So let's do this. It's not complicated, it's very simple. So it's Metasploit. Oh, I forgot to tell you guys, Metasploit is with Tenable now, okay? I think Tenable acquired it. Okay,
Can you
guys.
share your Can you share your screen, please?
I haven't even gotten to the link. Trying to find the link, but I'll be there shortly and I'll show you. Okay, this is where our VM comes to play. All right, this is where our VM come to play. So we won't go deeply into it, but I'll just show you guys what needed to be done to have Metasploit running in your system. So now we can go here and we go to Metasploit and we say Metasploit for Linux. maybe let's say Ubuntu or something. So when you go home, you download Ubuntu on your system and see if you have the framework on it, and you start playing with it. Okay. So now I think if you have Ubuntu already, you are good to go. So I'm gonna give you this link. You just follow this link. You have Metasploit running. And now, if you want to do cool stuff, you then go to YouTube and look for hack section, simple things, and start learning from there. So I'll post this link for you guys because I really want to expose you guys to anything, because some of you guys could be good ethical hackers without even knowing it. You just need somebody to expose you to something, and you take it from there. All right, I'm gonna post it here on our video, not our video, on our text resource area, so that you guys can do it. And I know all of you guys have a VM type 2 VM virtual hypervisor. So all you have to do, download Ubuntu, follow the instruction on there, like I showed you guys before. So follow this to get your Metasploit running, and you start having fun. And you don't hack people's system. Make sure you hack your sisters that you live in the same home with, meaning you guys are accessing the same modem. Don't hack the neighbors, please. It's against the law. In Europe, it's against the law. In America, it's against the law. Unless the neighbor make you sign a piece of paper allowing you to hack into it. Are you guys paying attention?
So I have a question. How do you
I
know
don't
if
think
somebody is doing that to you?
Huh?
So how would I know if my neighbor is getting into my server?
You
Can
would
I
know.
know?
You would know because your network will show all the devices and MAC addresses of everything that's on there. That's why it's advisable when you get your modem, you go and check all your devices at home, your kids' mobile devices and everything. You get all their MAC address, and you give them access, and then you shut out everybody else. That's how you do it. But a lot of people don't understand how porous and weak the online is. But that is why I'm doing what I'm doing today. I'm promoting and letting everybody know you are out there in the open. You need to protect yourself, basically. So you will know once you start getting used to the network, what's going on. You will start noticing different machines in your network. And if you don't have a password for your Wi-Fi, yes, you'll start noticing a lot of that. But if you have a password for your Wi-Fi, I don't think anybody will get access. But if they try harder, depending on what you are using for, depending if you are using TKIP for AES, I mean WPA, or you're using WEP and stuff and several like that. But once you get Metasploit to your system and you start looking into all these avenues of hacking into stuff, you will recognize that almost anything is hackable. You just have to be patient with the right skills. So that's that. Let's move forward. So I don't know if I want to make this a homework, but I shouldn't make it a homework. It wouldn't be fair. This is some sort of like an advanced skills, but I would like for you guys to at least stand up an Linux operating system in your system in your computer and load it with Metasploit and at least show me that you have Metasploit. That's good enough for me. And then that's an exposure that you need, to be precise. So moving forward here, I think I've done justice to that. So moving forward, well, okay, vulnerability, we've defined what it is, we know what it is. So sensitive data left behind the file names and all of that, file system, they could be vulnerabilities, okay? Temporary files, etc., and etc. Because somebody can go there and get the information that they need to break into your system. Unprotected local data may have loose permissions and lack encryption. Vulnerable applets, browsers, and other client applications employ applets for viewing documents. When you hear applet, your mind should go to JavaScript, okay? And the old VB language, which is dying. Do not learn Visual Basic at all in your lifetime. Forget it. It's dying. So you have weak or non-existent authentication. Authentication methods on the client or between the client and servers may be unnecessarily weak. Substandard key management Default or weak username and password, insecure network services, lack of secure update mechanism. These are examples of vulnerabilities. Weak password is a vulnerability. I can take advantage of it by brute force or using a rainbow table. These are some of the tools for hacking that you can get yourself used to. So in cryptography, can somebody tell me what cryptography is? Somebody, please.
What we use for encryption.
Yeah, yeah, describing it. You are describing what it does actually, but I need to know the definition. Did you say hide information?
It does. It takes something plain text and hides it.
Yeah, it's the science of hiding information, pretty much. Change the appearance of the data completely. You change the appearance of intelligible information to non-intelligible data. It's a science. It's developed to do that, and it's a body in cryptology. So you have cryptography, and then when you go to implement the science, you call it encryption. Okay. So the purpose of cryptography, which I happen to be an expert in, the purpose of cryptography is pretty much to make sure the CIA tenets are upheld. What are the CIA tenets?
Confidentiality, integrity, and accessibility.
Exactly. Availability, actually, not accessibility. However, you can also have non-repudiation, which means when I send you a message, I cannot deny that I sent it to you because there's something in that message that points to me. It's called digital signature. And then you have access control. Okay, so access control, if I don't have what is required, I can't get access to the system. Only those that have what is required can get access to the system. If the right person gets access to the system, what does that mean? It tells us that the system is correct. Then if the wrong person cannot get access to the system, it tells us that the system is sound. Right? Right? 46 panels. Are you guys with me?
Yes.
So if the right person get access is correct, if the wrong person cannot get access is sound. All right, let's not make it complicated. Let's keep it simple here. So system environmental security, security configuration in operating systems consists of potential damage from what? Electricity, water, fire, natural disaster, and a natural phenomenon. So environmental security is not the same thing as operating system security or operating or security configuration in an operating system. Environmental means environment, things that can cause problems in the environment. Water, fire, these are security what? Security risk. Water, fire, and they're also threat agents anyway. They can cause damage, right? Right? Are you guys there? My people are gone. Everybody's back. Yes? We all back now?
I think so.
Oh yeah, we are back. Awesome. All right, let me go ahead and share my screen. So let's get this going. I think everybody's streaming video out here. That's why it's happening. But it won't happen again, I promise. So environmental security consists of potential damage from what? Electricity or what else? All the natural disaster and like things like that. So if something is going to cause harm to a system, what is that? What can we term that to be? If something is going to cause harm to a system, what do we call that in security terms?
A threat.
It's a threat agent right there. So it's quite defined. It's a threat. So for environmental security, we're looking at things that had to do with nature, electricity, flood, etc., right? We're looking at those nature, flood, fire, water, and all those kind of stuff. That's what we are looking at. Okay, let me go back to 49. I skipped a little too far. Sorry. Okay, now back here. All right. Okay, I skipped a little too far. Okay, we've already done this. So we are in cryptography, and we've done that. Non-repudiation, we've already done that. System environments. So we have environmental security, electricity basics, pretty much no single point of failure, 2 feet from different power substations, use of generators and batteries. Basically, what it's telling us right here is to avoid some of this that we've seen as environmental security, which consists of water, fire, natural disaster, and unnatural phenomena. For electricity, the basic is that you have to have 2 feet. So if this one goes down, this one comes up. Maybe you have a solar, and then you have the national grid. If national grid get knocked out, you have the solar. In South Carolina, most people have generators. If something goes out, they have the generators running, etc., etc. So for water, you have to use water alert detection sensor cables, so that if the water is running low or is overflooded or above the brim or coming off the brim, you'll be alerted. For fire, we have the fire extinguishers. They should be visible to where people can see them, so that those people can use them to tame the fire in event of disaster. With that being said, we also have natural disasters. For natural disaster, there should be incident response in whatever community that is. Hmm. Is everybody here? Is everybody here with us?
We're here.
Yeah.
Okay. All right. So you guys have an understanding pretty much of what's going on here. We are looking at addressing some of these security, environmental security scenarios. So we also have physical security. That one is easy peasy, very simple. You have the bollards, the deterrents, boundary restrictions, presence of security guards for deterrent as well, logging in file for visitors, denial, because you need to have the right key to get in. That's locked vaults, right? Detention using motion sensor cameras and delays, like cable lock on assets, like for your laptops in some stations or in retail businesses. You have fences, barriers, access control list, smart cards, etc. Assessments. Again, security guard procedures, communications, and response forces, emergency procedure, police, fire, medical. These are all physical securities, okay? And another important aspect of site and facility design is the proper convergence between the physical layout and the physical security plan. Achieving all the goals of CPTET, you can Google that, is not always possible. And in cases where a gap exists, the physical security plan should include policies and all procedures designed to close any gaps. The plan should address the following issues: strategy for physical security, administrative physical security controls. And for strategy for physical security, the security controls implemented to manage physical security can be divided into the three groups: administrative, technical, and physical. That's how it's always been. You have administrative, you have technical, you have the physical. So administrative has to do with the high level on how things should be for that control. And the physical is, and the technical is like what device, what technology are required to do that. And physical is actually putting those things in place. Okay, so let's look at the administrative physical security control. For selection of sites, a number of decisions has to be made by the executives or the people in the management. Will the site be externally marked as a data center? Is there a shared tenancy in the building? Meaning, are we the only people sharing this? These are the considerations given when there are security issues. All right. Where is the telecom demarc? Where does the cable come in from, or the phone, etc., etc.? Is it exposed to the public for somebody to tamper with it? So the site selection should be based on security needs of the organization. And below we have an explanation of common question that pops up in the decision making. So you have so some of the support systems that are built into the system, they play a large role in overall physical security posture. So hence there are multiple factors that we need to look into while designing security administrative controls. So with that being said, we go into technical and physical controls. For technical physical controls, you have to look into how the cable from the DMAC is brought into the cable box in the organization, and what are the switches and routers that are going and where they're going, what type are they locked in, etc., etc. Are they in the server room? Are there media rooms? Who handles the media rooms? Are there security guards there, etc.? So the only thing missing here is the paper here did not talk about. It didn't talk about. We talk about administrative control, right? We talked about administrative control. Talked about technical control, but it did not talk about. Take note. It did not talk about the other one, which is physical. So what we say, oh, physical, or is actually when you put it in place, I guess. But it should have been written down here clearly for us. So now with that, we move on to the fourth domain, which is communication and network security. The third domain is identity access management. People get paid doing identity access management work. All these domains, people get paid doing or knowing very well each of these domains. So you have communication and network security. Okay, so this is where OSI model comes into play. These are IP models. You have telecommunication protocols. You have security components and security components. Sorry, and secure components. You have vulnerabilities and attacks. We've heard some of this before. So you have OSI reference model, network protocols, network connectivity devices. You have threat to network security. You have firewalls, and you have wireless communications. So OSI model stands for Open System Communication or Open System Intercommunication. It's a conceptual framework. It's a model as well. It's a conceptual framework used to describe the functions of networking systems. And the OSI model characterizes computing functions into universal set rules or set of rules and requirements in order to support interoperability between different products and software. Are you guys all with me?
Yes.
So we've seen OSI model before. I don't know if anybody remembers the acronym for those. If you do, can you let us know? Is that not right here in front of you guys? Can you guys see my screen?
Yeah.
No, teacher, I can't see. I think you need to share your screen, boss.
No, you can't see my screen, huh? I'll try to share it.
Oh, sorry, I have it up.
Does anybody remember the OSI model acronym to pretty much?
Throw something. Please do not throw sausage pizza away.
That's right. Please do not throw such piece away. And that tells us that we have the application, presentation, session, transport, network, physical. But actually, the way it goes is this: the the whatever you're sending to somebody comes to that person as an electrical impulse, right? If it comes to that person as electrical impulse, how do you think it gets to the computer then? Logical question. Simple.
Is it a way pizza sausage throw not do, please?
No, I'm saying that if you send a message to somebody
Mm-hmm.
and the person gets the message,
Mm-hmm.
how does anything come across in a virtual environment, especially when it's an electrical component? How where does it begin for the one receiving the information? Straight to the point.
Are
Where
you
does it
referring to the
begin?
application layer?
No, for the one receiving the information, where does it begin?
For the one receiving it
Mm-hmm.
would be, I don't know if I follow you, but in order for me to get something that you're sending, I'd have to have, would it be the presentation? Like it would come through like a document, or would it come through some other way, you're saying?
Don't you have to first of all? Don't you have to have your computer hooked up on the connected to the network?
Right, okay.
If you don't have
Yeah.
electricity, how can you get whatever I sent you? So what does that tell you? What level are we coming from then? If I'm receiving the information, how does the information get to me? What level in OSI model? It's physical layer because the data comes in as zeros and ones, electrical impulses. So it's this physical layer. So once it comes in as zeros and one electrical impulses, it will now be formulated into what? The little strings will come and be put into little fragments, which is called datagrams. And from there, they form into packets, right? And when you hear packets, what does that tell you? What layer is it on? Hmm? What does it tell you? So you have the data link layer, you have the datagrams there, and now you have the network layer, you have the packets, IP packets, right?
I thought it would be more the application layer to see, I don't know.
Same.
Application.
I thought it would like work backwards. Like I thought I was doing bits as well. Then I was like, I was getting gas, and it's like, no. I was like, wah, wah, wah.
So for the application layer, if you look at the way it's set up, you should know that if you're getting a message from someone, it
Can you
comes to
share screen, please, Teach?
it keep coming out, huh? Every time. We're having the problem we have the last time now, and I don't know why. I thought I solved this problem. So now, if I send a message to any one of you, your computer has to be on to get the message. So assuming the computer is on, the message goes through either Wi-Fi or Ethernet, which is low voltage. Ethernet is low voltage, so it's gonna go in zeros and ones. You have three cables on it, and it will stream 8 bits as they come in. Okay, so now that collection of electrical impulses are gathered through the network you know, the network that you have. Okay, so it comes into your system and you get repackaged, not really repackaged, you get read as datagrams, and that's on the data link layer. Okay, so you have layer 2 switches here, which are not IP protocol, but then the datagram now is packaged into packets, IP packets, Internet Protocol. Okay, so once you hear packet, you remember Internet Protocol. So once it gets to the network Internet Protocol, that means wherever is coming from is now making it so that it will have all the right information for the target, and now it will send that out to wherever it's going. But whoever is going to receive this information has to go through the process upside down. So if your computer is on and you are feeding information to the computer and you send the information out, it has to go through this process until it gets to the application. So when it gets to the application, if you are doing FTP, that's when a session is created so you can do your file transfer. If you are checking in something in the web, that's where you have the HTTP working for you, or HTTPS. If you are doing telnet, that's where it starts working for you. Okay, so it doesn't, when you send a message, it doesn't straight go to application. No, it has to go through the process to get to the application. Application is when whatever is sent to you is presented for what it is. And now application is applying what that particular utility is supposed to be doing. Okay, guys? So when you are receiving information, this is getting a little this is becoming a little too much now, and I don't know why. We had a 500 MB internet, high-speed internet. Still, we're having the same problem we had the last time. I don't know how to explain it. It breaks my heart right now. We got a really high-speed internet, and it's doing this. Okay, let me change it to another one. Are you guys here with me? Is this God is Love 2020? The internet. L is capital, right? Man, I don't know what happened with this internet, man. Keep signing me out. Class is broke now. Right? Huh? Man, this is bad. You signed me out completely. Is it capital L? So the problem is with them. Right? It's messing up the class. Content secure.
Fam, ban your ass.
I told you about the English language, okay?
Alright, we're back now. So hopefully it's gonna be alright this time. We have to place a call to the company and tell them, hey, look, this thing is 100 MB, but it's acting like 20 kbps. So, all right. Anyway, so the process is very simple. Remember, when you are receiving, you go from down to up. But when you are sending a message, is in the application you send it. So it's like a cup, right? Let me give you guys an idea. Let's go to Paint. It's like a cup. Everything is underneath. You guys will understand it now when I do it this way, okay? It's not hard. It's just simple. Just you have to rethink how you see things and develop a system for yourself. So let's say the physical is here, right? Huh? And everybody with me? Is everybody with me?
I can't see your screen. Are you sharing?
Where are my people? Where are my people?
I'm here.
I can hear her.
Okay. They said I'm not sharing, but I'm sharing. But now I'm gonna share again. And I'm sharing. This is it. Now I'm trying to show you guys an analogy with paint so that the confusion will destroy the confusion once and for all, and it will never exist again in our lives. So we have the physical, right? We have the data link here, right? We have network here, right? Is it not transport? It's not. Is it not presentation? Is it not application? It's 7, right? Please do not throw success piece away. So let's say that we give it that color. Let's say we give this one this. Let's say we give this one whatever color we choose to give them. We give this one blue. We give this one purple. We give this one this. Okay, that's fine. So we have application. If you are receiving the information, like you have to package the information like this to send it out. This is how you package the information to send it out, okay? All right, so I'm gonna include everything in here for you. All right, so we make different shapes and we decide where they're gonna be. This is physical. Let's say this is application, right? Let's put application at the top. Let's put application at the top, okay? We put the application at the very top. think I changed my mind. Let me make this one bigger. Alright. I changed my mind what I want to do. I make that one bigger. Alright. Okay. Now we go to presentation. This is presentation. If application is there, presentation then is gonna be here. Presentation will be here, right? And then we're gonna take care of this. Okay, next one is session, which is that. This is session, which is that. Okay. This section, that's that. Okay. Then we go to the next one, transport, which is the blue one, I believe. We put the transport here, right? Okay. And that's the transport here. That's transport. And then you have the network, which is the purple, I think. You put the network here. This network. Are you guys following me? Please follow me here. It's very
Yes.
important. Okay, now we go to data link. I believe this is data link. Right. This is data link. I think this is the color. I mean. Okay. We put this one here. You see how you unpackage it when you send it to wherever you're sending it to. It will be brilliant when we unpackage it. Okay. Now you have the physical, which are just the wires, right? It's black again. So we wrap it up with this. This is the physical. All right. Okay, this is physical. All right. So now you send this out to somebody. Say this is your whole message. The message, this is how it's translated. You send it to somebody. Guess what's gonna happen? This thing is gonna be inverted. So I'll copy this. Guess what's gonna happen for the person to get the message? In their own system.
It travels through the layers.
No, in their own. What did you say?
No, I said it travels, right? Through the layers.
Yeah, in their own system, this is how it's gonna happen now,
Right.
right?
Okay.
So they're gonna do a physical, they're gonna do data link, they're gonna go to the IP because that message has to be sent, right? It has to be sent. For it to be sent, it has to be packaged as an IP, which contains the source and destination of the information. So when the thing comes in through a network interface card, this is what's going on in the network interface card until it gets to the application place where you start reading it. It gets to the presentation is where you see what you're about to read, and when you start reading it and doing what it's supposed to be doing is then the application. You're interfacing with the application. Okay, so the person that's sending it to you did the work on application layer, you see, and then they send it to you, right? So for you to get the message again, this layer has to interact with this layer, but behind the scene it cannot just interact directly with you cannot just directly interact. This is computer A here. Let me make this clear. This is computer A here. This is computer A. That's right. and this is a computer B. You can't just the application layer can't just interact with this layer like that. It doesn't work like that. It has to go through the protocols that are set out for it, and then it works. So now, if I have let's say an email, it will fall under SMTP, yeah, right, guys. SMTP will be on this level, right? Right? Everybody with me?
Again?
Yeah.
No, say that again. If you're sending an email.
If you are sending an email, emails usually will go through email client is POP, SMTP, and all of that. These are applications, and they will be on application layer, right? Now, how can this email that you're sending that goes through this kind of application get to this person here? Is the question. So in the process, you recognize that if you package an application, email application here, okay, so that email application eventually have to be repackaged to obey the network, to go through the network. For you to go through the network, it has to have what? Source IP and destination IP. And you can see all of that in the header of the email. If somebody sends you an email and you want to find out where they're sending the email from, check the header. So in the header of the email, you have to see the source and destination of that. So if you see the source and destination of that, it's telling you there's a protocol being used here. Right, guys? So
Yes.
the protocol used here is SMTP, probably POP, and etc., etc. And if you look at those protocols, they have a part in them that recognizes the network layer. Okay? If you see the network layer, then it tells you that IP is involved. There are routers involved. So if you send something from one router to another, you can send something from one router to another. You see? So whatever you package up and written and you want to send to the other person, for them to receive it, it goes backwards this way and goes back to the application again. Then they can read it. That's all I'm trying to teach you guys. Okay? When the person prepared the information, they prepared it here. When they send it out to you, it goes through this process, you get it here. On your computer, what happens on your computer is this, that you get presented with this information and you read it here. So if you remember in TCP IP model, if you remember TCP IP model, it's close to this, but it's kind of different. It kind of did it differently, whereby it shows you the application layer, network layer, application layer. Pretty much it starts with the physical layer, network layer, application layer, and it shows you that. I think it have 4 layers for TCP/IP. It has 4 layers. The first layer is, I believe, is the physical. Okay, so in the physical, I think it combined application and I think it combined physical and data link together, and then it has the network layer, by itself. Then it has uh, the transport layer with the section combined together. Then it has the application with the presentation combined together. Remember? So now, if you send somebody stuff, don't expect that it magically gets to the person. Email, no, it didn't magically do that. It has to go through the process that it requires for the person to get it. Because when you send it to go, it's gonna go. How is it gonna get to the person? It's gonna jump through the networks. Okay, when it jumps through the network, it comes as zeros and ones, electronic signals. It grabs it. It takes the physical layer, whatever is in the datagram, and it goes to the data link and it split it up to see the source where it's actually going, the destination where it's actually going. Once it sees it, it sends it through the transport layer. Okay, it sends it through the transport layer. It goes to the destination. Session is created. Once the session is created, what happens? You see what you are looking for. Okay, once you see what you are looking for, now you can send and receive stuff using that application that you have. Does that make any sense?
Yes.
Yes.
Exactly. So now you have understanding, a very good understanding of how network works. So, oh, you're sending me an email. Well, that email is gonna come as zeros and ones through my network interface card. And if it comes as zeros and ones, we're gonna package it back over to Datagram all the way to whatever level. But if you already received it, that means the network layer is already done. So if you already received the network layer is already taken care of, you already received that. Okay. Now you have to go through the next process, which will be presentation and you're working with the application. So that's basically it for that. I think there's a video online that I can send to you guys that can help you guys understand it. I've seen that video a long time ago, a couple of years back. Let me see if I can find it here quickly. It will help you guys to understand the whole thing. I don't know if I've given it to you guys before, but we can find it. Understanding iOS model with simple analogy. If I see the one I will know, I'll just point you guys to it because I've seen it before. I check for stuff like this to help people understand processes. I don't like complicated processes. I like simplified ones. So let me see. Oh, OSI model. I think it's this guy. Let me see if it's him. Now, a lot of people talk about a lot of stuff, but some people are really good. It might be this guy. Can you guys see it?
Yes.
I can see it.
It might be this guy. If it's this guy, then I'll just send you guys the link. I'm not sure if it's this guy. I'm not sure, but let's see.
Now, on this video, you and I, we're gonna go through this process. I'm doing an exercise, and let's see how much can you say about the OSI model, anything that you can think of, anything that you know, but
It's not
under
this guy.
7 minutes. And you better go through this exercise.
It's not this guy. This guy might be good, but the one I want to show you guys is completely different. Maybe I should say TCP/IP. Yeah, let me try that. It's not this guy. No, not at all. I saw that a long time ago and it was very simple. Oh, no.
I watched some videos or books on Mike Myers.
No, this thing I'm showing you is very simple. Trust me.
Learning new things is fun, and oftentimes
Let me
if
see
you're
if
learning
it's this
something
guy.
new, the application layer service
It's this
is
guy.
going to be
That's
something like
him.
HTTP. The layer 2 over the network and the protocol
Hold on.
app or
That's him.
service of
That's
the
him.
application layer, and we're going
Amazing.
to choose DNS.
So I'm gonna post this
And from
link
our
to you
previous
guys. You
nugget,
guys will
DNS
get
is
it.
used
Once you
behind the
guys
scenes
watch it
when
once,
Bob tries to go to
that's it.
www.
Hey.
Kind
That's
of
it.
some distractions back there.
Yeah, that's Natalie. Natalie is very unconventional. She's different. Yeah, she's fun though. All right, let's see this here. I'm gonna post this thing for you guys right here. That's the guy, and the way he explained it is so simple. Like he showed it with that little cup thingy. Oh, can you guys still see me?
Yeah.
Okay. So now we still like the excitement in the class. It's fun. All right, so I posted it. You guys should watch it. And so next time when we talk about it, it will be easier. And a lot of you guys will already know analogy and how it works and everything. So now, network protocols are formal standards and policies made up of roles. You guys already know roles. And the procedures and format that defines communication between two or more devices over a network. You have network protocols, conducts action, policies, and affairs, end-to-end process of timely, secure, managed data or communication. Yeah. So the network interface card is the beginning of everything actually. Then you have the hub, the switch, the bridge, the transceivers, the wireless access point, the router, and the gateways, which you can bridge. The router, you can bridge the router or make it a gateway at the same time. So there are some common network security threats. Can you guys mention some of it for those of you that can see the screen?
I have malware for sure, viruses.
Trojan horse and phishing.
Exactly, phishing is one of the most popular, but malware is getting grounds over the years now. It's becoming very, very powerful, and they're doing a whole lot of amazing nonsense with this malware business. There's a lot of money in IT, cybersecurity to be precise, and the men of the underworld are making a lot of money with this as well. And that is why we need firewalls in the network. What firewall does is it helps us to create rules that allows egress and ingress access to the network. Ingress meaning coming in, egress meaning going out the network. So firewall does that for us. We use it to open the right ports and close the wrong ports. And then we have wireless communication. Wireless communication is very huge. It's a totally different animal of its own. For those of you that would like to deal with radio frequencies, that's an area for you to look into. Now, well, wireless engineers make lots of money, but it's hardware though. So just to let you know. So we've done 3 and 4. That will be the conclusion of 3 and 4. And let's go back and do our favorite thing, which is Python. We have 30 minutes to finish it. So next, we'll do the security architecture, and we'll do number 6. We should finish this off on Tuesday. We should finish CISSP on Tuesday. Somebody did 5 and 6. I saw it now. Wow, that's amazing. And then we're gonna do whatever that's left. We'll just do whatever that's left, and that'll be it. And then we'll start taking the questions. I implore you guys to start gathering your question and answers, looking at the practitioner guide. I don't know how many of you, I don't know if you guys have forgotten that we have to accomplish that part of the whole process. Don't ever forget that. We will have to deal with, let's see, AWS program. So I don't know if you guys remember all of this. These are the higher level guide. Let me go back one step to take you guys to.
Yeah, we cannot see your screen.
Oh, you guys can't see my screen again?
No.
Whoever is doing this to us, man, don't worry. They will regret it very shortly. Now you can see the screen.
Thank you to whoever did 5 and 6 as well.
Yeah, you did 5 and 6. I saw it. Thanks a lot.
It wasn't me, but thank you to whoever did it.
Oh, it wasn't you. So we'll all right, they did a good job. So we have 1 and 3 taken care of. We just did 3 and 4 today. So we're gonna do 5 and 6, and then we're gonna do 7 and 8 the week coming. But now we have to focus on Python and cloud So I would say everybody should go and download. We do AWS Cloud Practitioner Guidebook. Everybody should go and get this. Not the book though. Sorry guys. Go to your AWS training. All right, like here. The training you should download. Let's go back to the training. AWStraining.com. We go to training.com. If you have an account there, you should be able to go in there and get the guide. And when you look at the guide, there are domains for that guide. And I've asked a question on that domain before, nobody answered it. I asked the question if anybody knows the domains for Cloud Practitioner, and nobody answered. That's how I knew you guys weren't doing it. So I decided today, maybe we should touch it. AWS Cloud Practitioner Essential. Okay. This is the one I want you guys to pay attention to. As you can see, I was looking at it myself. So you can watch the videos and finish the videos. It will teach you all the domains of it. And it will teach you all of that. It has...
In this video, I'll be covering details on AWS.
It has, okay, he's doing fundamental pricing. He's doing pricing detail, AWS Trusted Advisor, support plans and knowledge. So he's basically doing AWS Cloud Practitioner Essential Pricing and Support. That's just what he's doing in this video. However, this has a domain. So I need you to download the guide. Once you download the guide, you will know what is required of you in this exam. So now let's go ahead and get the guide. Let me see if we can get it here. So we have certification here, right? So we go to dashboard. Okay, let's go to that certification and see what we get. And the question is minus PSI minus. No, I will see that some of you guys register for these exams, but for now we want to get the guide. Normally the guide should be here. You'll be redirected to Metrics. I don't know why I can't find the guides, guys. Let's see, support, certifications. Okay, exam scoring, content, schedule, account setups. I think we've done some of this before. Okay, let's go. Certification, account setup, training. What is included in AWS digital training? So let's go here and see what we find. Do I need the log? Oh, that's interesting. Okay. Are you guys there with me?
Yes.
Can somebody type in practitioner guide? I used to have the guide. I don't know what happened.
Practitioner guide.
Practitioner study guide. Yeah, AWS practitioner study guide. I used to have that. AWS practitioner study guide. Aha, there we go. So we want to do foundational, guys. This is it. Download the exam guide. Okay, this is actually the first one. I'm gonna download that. I'm gonna save it. So you guys give me a minute, I'll be right back. So we can go through some stuff. This is the bare minimum. This is the first one actually. All right, guys. Are you guys there?
Yes.
Okay. So if you
Here.
look at it, if you look at the training and certification, AWS Cloud Practitioner is CLF CO1 exam guide. So this is, I guess this is the first time I'm introducing this exam guide because I really think that we should take, every one of you should take this exam. We should do it. And this helps you to prepare you to gauge the knowledge that you've gathered. The beautiful thing about this is that this exam actually points out what is required to pass the exam. So it validates an examinee's ability to explain the value of AWS Cloud, understand and explain the AWS shared responsibility model. So in the shared responsibility model is that whatever AWS provide for you, they will give you security for, and whatever you bring with you, you should provide the security for it. You'll help us to understand AWS Cloud Security best practices, like when you go in and create an account in the console, you should remove the keys for the root and limit the, never use root to access it. Create an IAM so that you never use the root to access the console, right? And then it also helps us to understand the AWS Cloud cost, economics, and billing practices. Instead of using TC micro, C2, I mean T micro, you use M micro, when in fact you're not doing anything that demands for you to use M micro. These are the economics. What is the total cost of ownership as opposed to buying a machine? What is the cost of a gigabyte of uh, data you put on S3? How much does it cost? Have any one of you checked it? What is the billing practices? Is it monthly, bi-monthly? Is it on-demand billing, etc., and etc.? And you have to describe the position. You have to describe and position the core AWS services. Example: the compute, the network, the database, RDS, and storage like EBS, etc., etc. You also have to be able to identify AWS services for common use cases, S3 for data backups, and etc. and etc. You also EC2 for Elastic Compute Cloud, for additional web services, and etc. etc. S3 for pages, static website pages, and etc. and etc. You have to know what these are used for. Okay, so we've been studying for 3 months, which is good, almost 3 months, which is good, and we can do this. Okay, you guys can do this. Exam content. So you have the response type. These are multiple choice questions. You see, it has multiple responses, has one correct response and three incorrect responses. These are called distractors. So multiple response has two or more correct responses out of five or more options. So these are response types that they have. So you have the five of them multiple responses where two or more are responses out of five or more options. So you have one of those the multiple choices where you have to have two or three answers right? And then you have the multiple choices where only one is correct. So when you have only one is correct, you have to do use the elimination process, which a lot of people use anyway. So there's also unscored content. The unscored contents are the ones that they use to improve the exam questions and modify it. They gather statistical information from individuals. They ask you questions about your experiences while you're taking the exam, etc. With that they can gauge what people are supposed to know or what they are not supposed to know. At the same time, make the exam harder. So for the exam result, good news, good news. For this exam, you have to score 700. So they have the score from 100 to 1,000. Minimum passing 700. Once you get a 700, you're certified on this, you're good to go. You go to the next level. So these are the course outlines here. You have the cloud concepts. Number one, that's the first domain. The cloud concept, which I've been teaching, learning and teaching with you, teaching this to you guys and learning with you guys. We have the cloud concept. We also have the security and compliance. We have technology. We have billing and pricing. Billing and pricing is important. However, it's only 16%. If you noticed, Technology is 33%. What does that tell you? You need to know what you're doing. Hands-on is required. So let's go to billing. For billing and pricing, you have to compare and contrast various pricing models for AWS, okay? You have to recognize the various account structures in relation to AWS billing and pricing. You have to identify a resource available for billing, okay? You know that T2 Micro is available for billing too, although they said free tier. But if we go beyond the spaces that they allow, or the input output, or the data that you're moving back and forth, they're gonna charge you for it. Okay? So for technology, you need to know the method of deploying and operating in the AWS cloud, define the AWS global infrastructure, identify the core AWS services, and identify a resource for technology support. And then for domain 2, you have security and compliance. Do you see now why security is important? They even have it here in the cloud. So for security and compliance, you have to define AWS shared responsibility model, and you have to also define AWS cloud security and compliance concept, and you have to identify AWS access management capabilities, which we have already shown you guys how to build it to the IAM. You have to set it up, set up group security groups. You also have to create responsible policies for these groups, because if you create a particular group for S3, and then you want that group to access EC2, it's not going to work. So that means you either involve the roles of EC2 administrator in that same group that you are using for S3, or AWS SDK group, which contains the S3. You have to know all these things, okay? And you have to identify resources for security support. Now, the cloud concept is very straight to the point. Define AWS cloud and its value proposition. Identify aspects of AWS cloud economics. List the different cloud architecture design and principles. So we'll go through all this. Now you guys have a clue of what we're going to be doing with this AWS cloud, as we're going to converge to it fully, and we're not going to do anything else. So with the next 13 minutes that we have, we're going to do a lot of Python. And Python is our best thing moving forward. So we're not going to play with it. So how many people did the backup? How many people did the backup?
I haven't done it yet, sorry.
Well, I'm just here. I want to know what you guys are doing, because I want to make sure everything is done well. And we're going to have to take that exam, you know. We're not just doing this for fun. We want to get a job, right? So we have to push ourselves even when we think we cannot do it. All right, so with that being said, I recommend that people look into the roll call list and see what they haven't done and complete those. Please, please, please try to get together when you are not doing anything. That you can't go around by adding a bit more to what you know on a regular basis. You cannot. It doesn't hurt anybody, and you cannot go around doing that. So we've done this. I want to try to introduce you to object-oriented programming. Can somebody tell me a little bit about object-oriented programming for those of you that are reading the book? So we've been doing procedure-oriented way of programming, but now we want to do object-oriented way of programming. And the question is, what is that? Can you guys hear me? Can you guys hear me?
Yes.
So anybody knows when they're talking about object-oriented programming, what they're talking about?
No.
So when they're talking about object oriented, but what we've done so far, we've used function to perform what we needed to do. These are procedural. Okay, these are procedural way of programming. But there's another way of programming that is very powerful. It's called object oriented kind of programming. So in object oriented kind of programming, you have classes. So you have a class, and that class are objects. Objects are instances. Objects are instances of a class. So if you create a class, like say a dog class, in a dog class, you create instances of different kind of dogs. So the code is reusable. So that means anybody that have that class can now create instances of the dog classes and do whatever attribute that you've given that is there for a particular dog. An example would be in object-oriented programming. I'll try to give you guys an example. An example would be like, for instance, I have a car. Regularly, we will do. Okay, this is a car. Let's not say a car. Let's say automobile, right? Or automobile, like they say in America, automobile. So under automobile, what are under automobile? Come on, guys, tell me. A car, right?
Okay.
A car, right?
Yes.
Even a bike. Then you have a car. And then you probably have a truck.
A train.
And etc. etc. All that. But under a bike, what are the attributes of a bike? If you write the class of a bike, you gotta respect some things about a bike. You're gonna say a bike have two tires, right? Right? And it has
Yes.
one seat,
Yeah.
right?
Yes.
That's one of the ways you can describe a bike. But when you come to writing a car, you can say you can take the same object, bike object that's under the automobile class, and you can say, oh, let me add stuff to bike. Instead of two tires, I say four tires, right? Instead of one seat, I say two seats, depending on the type of car, right? Right, guys? Right?
Yes. Yes.
And then when it comes to car, you can say, oh, for truck, you can say instead of uh, uh, four tires, you can say more than four tires. Remember, what you are doing, you are adding to things you already have. So now you recognize an automobile class has some specifications that is defined in the constructor. But in order to expand it and do what we call polymorphism or encapsulation, polymorphism, and inheritance, you have to do it this way. So that's how the object is distributed. So you have a class, an instance of the class, meaning it's an object that does what the class is defined, what is defined in the class. And now, if you want to carry on and do other stuff, you have to now modify what is in a particular object of the class, and so on and so forth. So that's what we have there. So in object-oriented programming, it's like you making the code very versatile, and it's not just procedure, just you write the procedure, have base and height, you define the function and use the function, and that's done. No, in object-oriented, it's more encompassing, it does a lot more. So classes and objects are the two main aspects of object-oriented programming. A class creates a new type where objects are instances. Okay, so you have automobile class, all right? You can have a car class. In a car class, you can have different kind of cars, which now becomes an object, inheriting the car class definitions. So that's that. So a class creates a new type where objects are instances of the class. An analogy is that you can have variables of type integer, which translate to saying that variables that store integers are variables which are instances of the integer class. Okay? Alright guys, so this is about object-oriented programming. Objects can store data, alright, using ordinary variables belonging to the object. Variables that belong to an object or class are referred to as fields. So if you have a variable that belongs to a class, to an object or class, it's called a field. Objects can also have functionality by using functions that belong to a class. Such functions are called methods of the class. So you can liken this to a function. So you can have a class. In that class, there's many functions or methods of doing a particular thing. Example would be a method for calculating a triangle. As you well know, we had defined calculate triangle function. So when you look at class, you're looking at it as a bigger aspect of something. You're trying to bring physical things into the virtual world and give them the attributes of the physical world using software. So this terminology is important because it helps us to differentiate between functions and variables which are independent and those which belong to a class or object. Collectively, the fields and methods can be referred to as attributes of the class. Fields are of two types. They can belong to each instance object's class or they can belong to class itself. They are called instance variables and class variables. So they can belong to the instance object of the class or they can belong to class itself. So you have the field can be a part of the object and also a part of the class. That's interesting. So a class is created using class. That's the key word. These are reserved. You can't just name anything a class in Python. So these are reserved. Class is a keyword in Python. So the field and methods of the class are listed in an identical block. Okay, you have the self, okay, like here. So class method have only specific difference from other functions. They must have an extra first name that has the added beginning of the parameter. But you do not give a value for this parameter. When you call the method, Python will provide it. The particular variable refers to the object itself and the convention it is given the name self. Right? So you have a class, a person here. You have a person class here. The simplest class possible is shown in the following example. So you have a class person and you have this is just an empty block, okay? You have a class person, you have pass, and P is person, which is a function, and you print P, it prints the function, right? So now let's go back and see what the pass is. Okay, let's go back over here. Say you have a class called myClass and an instance of the class called myObject. When you call a method of the object as myObject.method, you see, you use the dot to access the method. This takes two arguments. This is automatically converted by the Python into myClass.method, myObject. Argument 1, argument 2. This is all the special self is about. So this is for the self class. Okay. So now let's look at the example of the class that we are given here. And we go and bring up our favorite editor and IDE. I like to use Mu. You guys already know the reason why I use Mu. Everybody with me? Everybody with me? I can't hear you guys.
Yes.
Okay, you can hear me. Awesome, awesome. All right, so we have an empty block here, but we're gonna go ahead and do it. Do justice to it. I don't know why it didn't show up, but we'll figure out why. Okay, popped up. So I love my repo. I'm just gonna go to repo and copy that thing there. Yeah, hopefully, I hope it works for us because we want to close on a very large note. So it worked. So what we see there is the man, because it's an empty stuff, we have the man accessing the person object at that memory space, and there's nothing in there. You see? Does that make sense, guys? So we just pass an empty block right here. The pass is to show that we pass an empty block, right? Are you guys with me? Everybody with me?
Yes, yes.
Okay. So this is how it works. It's very simple. So this is followed by an indented block, the body of the class. In this case, we have an empty block, which is indicated by using the pass statement. We just pass an empty block. So next, we create an object instance of the class, which is p is equal to p person function, followed by a pair of parentheses. Then for our verification, we confirm that the type of the variable by simply printing it. We printed p is equal to person function. Person function is an inbuilt function. It will find what's in the person and put it in there. So we have an instance of the person class in the main module. So that's it. So this is at this location right here. Does that make sense? Remember, we created a class here, right here, person class. But we say that the p is equal to person function, right? Or method, and we printed that p. Apparently, we pass an empty argument, so it's gonna go to where the method is. Which in this case, what does this p mean for you? What is this? Is it not an instance of this class person? Remember? Come on, guys, follow me. Follow me.
Yeah.
Right? So it's an instance of this class person. Class is pretty much a more advanced way, a better way of using function. Okay, it's a better way of using function. It has all the capabilities of not a procedural programming, but rather it's more object-oriented programming, whereby you have polymorphism, meaning you can use it in many ways, many other ways. You can apply it to other places. They're reusable, and you have inheritance where you can inherit um, an object, which is an instance of a class. You can inherit its attribute and modify it to get what you want. So you also have encapsulation. Okay, you have all of that. You have encapsulation, you have inheritance, you have polymorphism, and etc. etc. So object-oriented programming is much better than procedural programming, which is just like do this, do that, whatever. Object-oriented programming gives you attributes that you can get it easily from another just by calling that instance the object of that class. Okay, which is an instance. Or you can liken it as the instance of a class, but also an object can also have its own instance. That's the beauty of it. All right. So what we've just done here is we pass an empty block, which means we didn't want to do anything. And then when we assign a function, inbuilt function to a value, the function wasn't even defined. Apparently, that function, okay, has a place in the memory which was called up here, which was called up here, which was shown up there. Okay. So now let's look at the method now. We have already discussed the class objects can have methods just like functions, except that we have an extra self variable. We will now see an example. Okay, this is a very interesting example. Look at what we've done in the past. We did the class person. We defined this, say hi. Say hi self. Remember that self function we talked about? Okay. So now print hello, how are you? Now P is equal to person function. Then P dot say hi. What would this thing accomplish? Can somebody tell me with your program in mind what this code is gonna accomplish?
Is it where the person is gonna say hi?
There you go. The person is gonna eventually the person is gonna recognize that they are part of the program. They're gonna say hi because here we're not passing a empty block. We have a function, a defined function. But what that function is gonna the argument is taking the self argument. You see, it's taking the self argument and we're gonna print hello, how are you? Okay, and then we're gonna assign the person function to P, and we're gonna ask the person function to access say hi. So it's gonna go to that place and take whatever the self, whatever argument that is in the say hi, and it's gonna spit it out. So let's try it and see how it works. Let's try it and see how it works. So now last time we pass an empty block. This time we define a function and we put it in there. But see how we called it. Isn't that brilliant? Hello, how are you? So the self is gonna take print hello, how are you? Self takes it. And now we use the function person to access that function that takes the argument self. Basically, we said print hello. If you print hello, take the string print hello, put it in self. So now use this function. We use this uh, person accessor function, which is inbuilt. Remember, it's capital P. It tells you that it's inbuilt. This function is inbuilt in Python. So we use that to access the say hi function and leaving the argument empty. And now it gives you hello, how are you? I think this is where we're going to wrap it up today. And I hope you guys remember and keep everything up to date as far as your homework is concerned. Take a look on the roll call and the list. Make sure you populate your name so I can keep a count. And next week, which is this Tuesday coming, well, this week, not next week, this Tuesday coming, we're going to delve into AWS concept as far as this referencing the practitioner exam that we are preparing for. We're going to take some questions that day. Your assignment is to download the guide and go through all its domain, and each one of you will have to teach us one of the domains, and this is serious. The game is now changed. Each of you will take one domain and teach us. If you want to teach us on cost, this is the time for you to shine. Are you going to teach us a whole full program on cost? If you want to teach us on architecture, compliance, and security, you teach us on that. And everybody choose what they want to teach. Whatever nobody want to teach, that's what I'm going to teach. So this is the way we're going to do this, and we're not going to hide behind anyone. We're just going to be a participating part of the whole team. We are team members, and we can work together here. So as you can see, we are winding down to wrap this thing up, and it's time for us to start addressing the questions and start doing more of use cases again. And Python, like I've said to you guys, is very, very important. I'm not going to let anybody off the hook with Python. So we're going to wrap up our CISSP. If we can't do it at one time, we're going to be doing it. We do the security, we do the Python, we go back to our questions on clouds, and we do it like that until we wrap up. And if anybody has any other use case they want to do, let me know. If not, I'll go ahead and do the ones that we have for our company Lockdown LLC, and I'll walk you guys through it and hope you guys have a lot of fun when we do it. Now we're gonna wrap up, and I hope you guys have enjoyed your day today. And we want to thank Lockdown LLC for the opportunity and supporting the program and the implementation partner. Also, we want to thank this Josiah again, your lead instructor. Thank you for coming to the class. And we'll stop recording now, guys. Thank you for
Thanks,
joining us.
Teach.
All right. Thank you.
Thank you so much.
All right. Appreciate that. Appreciate that. Thanks a lot, guys.